We're going to learn how to do a confidence interval using the same example that we pulled from earlier in the chapter. So I'm going to go back to our example where we have up here, here's our information about our sample. So sample information. Remember, we were working with a variable of a thermometer rating. Our n equals 100, our sample mean equals 58, our sample standard deviation equals 24.8. And we calculated a standard error of 2.48. And I did a quick little calculation to look at what this standard error means. The standard error, 2.48, can be plus or minus. You might be tempted when you look at the information about how to calculate a confidence interval to write out the mean, 58, plus or minus the standard error, and then say that this is your confidence interval. That is false. So I wanted to point out this sample or this example where we were figuring out just the standard error. Here's how you take the next step and calculate a confidence interval using this information of the standard error. So, and I do want to give a caveat, you are going to be able to use confidence intervals only when your n equals more than 30. You cannot use confidence intervals if your n is less than 30 because the confidence intervals are tied to the assumptions of the central limit theorem. So here's how you calculate a confidence interval. And again, I'm going to use it for the same example. So I'll try to move the paper around to show you what I'm working with. So using the formula from the book, let's first look at a 95% confidence interval. So a 95% confidence interval is going to look like the upper boundary. So I can say lower or upper. It kind of doesn't matter how I write it. So the lower is going to be equal to, in this case, I'm using the sample mean of 58 minus, and I'm going to use 1.96 because that is the score that is tied to the 95% confidence interval. And I'll show you a quick trick for how to determine this in a moment. But let's get back to this example. So the lower confidence interval for 95% is going to be my sample statistic. In this case, it's my sample mean of 58. And then I'm going to subtract 1.96 times my standard error of 2.48. So again, my lower boundary of my confidence interval is going to be 58, my mean, minus 1.96 times my standard error. So that's what I'm calculating here. So I'm going to look here. 1.96 times 2.48, 4.8608. So it's going to be 58 minus 4.8608. Minus 4.8608 equals 53.1392. So that's my lower confidence interval, and then my upper is going to be 58 because again, that's my mean plus 1.96 times 2.48, and I already know that's 4.8608. So 58 plus 4.8608 equals 62.8608. So my confidence interval for 95% confidence interval is 53.1392 to 62.8608. And I'll show you really quickly how to do the other confidence intervals. But I want to remind you about where we got this 1.96. That's actually from over here. That is from our z-score. So when I'm looking at my z-scores, this is how you calculate confidence intervals. So the z-score of 1.96 is the 95% confidence interval. My z-score of 2.58 is my 99% confidence interval. And in my 99.9% confidence interval is 3.29. Your book includes a 90% confidence interval. We do not see that as legitimate in most social science research. So let me show you really quickly. I'll give you a sample problem. So if we were working with the same sample and I was giving you the sample information, so let's look at this problem. So the sample, our variable is again the same thermometer variable. Our n equals 100. Our mean equals 58. Our sample standard deviation equals 24.8. So if I'm given this problem and I tell you, here's your sample, here's your variable, here's your n, here's your mean, here's your sample standard deviation, how confident can you be in a particular range of answers? Or what's the 99% confidence interval? If the question is, what is the range of data within this 99% confidence interval? I can look to see, and I'm just going to use for 99% confidence interval, my lower band is going to be my mean minus, here it's not 1.96, but again, I'm going to look at my little cheat sheet and it's 2.58. So my z-score for 99% is 2.58 times, here it's going to be my standard error. So the first thing that I need to do is to calculate the standard error. We already did that, so that's where you would use your standard error calculation equals my standard deviation over square root of n, 24.8 over square root of 100 equals 2.48. So I figured out my standard error because I need that for my confidence interval. So back to the confidence interval, my lower band at the 99% level for this particular sample and this particular variable equals 58 minus 2.58 times 2.48. 2.58 times 2. So that is 58 minus 6.3984. Minus 6.3984. 51.016, and then I would do the same for the upper. So my upper band for the confidence interval, again, is the mean minus that z-score times my standard error. So it's just going to be, it's just going to be plus. So 58 plus 6.3984. So it's going to be 64.3984. So now what I can say is that I am 99% confident that my data are going to fall between, or my cases are going to fall between 51.6016 to 64.3984. Again, that's my 99% confidence interval. So that's how confidence intervals work. They are opposite at this point to the z-score. And we generally just want to know where the data are going to fall. And again, you can only use this if your sample size is large enough.